In this video, I'm going to show you how to expand and condense logarithms. To do this, we're going to need to make use of the product rule, the quotient rule, and the power rule. The product rule just says that if we have a product of terms inside of a logarithm, we can split it into the sum of logarithms of those terms. The quotient rule, on the other hand, says that if we have a quotient of two terms inside of a logarithm, then we can split it into the difference of logarithms of those two terms. And lastly, the power rule says that if we have some number raised to some power inside of a logarithm, then we can bring that power outside the logarithm as a multiplier. So that number times the log of the base of the exponentiated term. Let's do some examples. For our first example, we're going to condense this logarithmic expression. We can't use the quotient rule or the product rule until we have logs by themselves. We don't want anything multiplying the logs. So we can use the power rule to get rid of that 5 in front of the log. So the power rule says that this term, 5 log 3x, is equivalent to log 3 of x to the 5th. We can take that number and put it on an exponent of the term inside of the log. And then we'll keep the other terms the same. Log 3 xy plus log 3 of y. All right, now we can go ahead and use this, we can use the quotient rule on this difference here. And then this difference just turns into the log of the first term, x to the 5th, divided by the terms in the second logarithm, xy. And we'll wait until the end to simplify this. So we've still got a plus log 3 of y at the end, but we can, since this is addition, we can use the product rule to combine the logarithms. So adding these two logarithms means that we can take the log and then put all the terms on the inside and multiply them. So we've got x to the 5th y over xy. Okay, great. Now we've condensed it into a single logarithm, and we just need to simplify a bit. So we've got log 3, and these y's cancel, and that x cancels, and the 5 turns into a 4. So just log 3 of x to the 4th. And there we go. That's our condensed version of that logarithmic expression. Here's another example of condensing logarithms. So to start off, we're going to want to move these coefficients inside of the logarithms, because in order to apply the product rule and the quotient rule, we can't have coefficients on the logarithms. So we're going to start off using the power rule, which will allow us to take the coefficients and put them as exponents on the terms inside of the logs. So this first log becomes log 5. The 4 moves from the outside onto the x exponent. So log 5 x to the 4th, then we've got plus log 5 y to the 1/3, and then minus log 5 of the quantity z plus 1 to the 1/2. All right, so now that we don't have any coefficients on the logs, we are free to go ahead and use the product rule and the quotient rule. So we'll start off using the product rule, because the first two terms have a plus here. And when we combine these first two terms, we just multiply the insides, and we get log 5 of x to the 4th times y to the 1/3. But then we've still got our minus log 5 of the z plus 1 to the 1/2. And to combine these two logs, since there's a minus sign, we can use the quotient rule. So combining these two logs, the expression inside of the first log becomes the numerator of the fraction. So log 5 of x to the fourth y to the 1/3 over, and then the expression side of the second log becomes the denominator. So z plus 1 to the 1/2 on the bottom of that fraction. And then lastly, we can simplify a little bit. Some of these exponents are fractional, which means they can be converted into roots. So x to the fourth stays as x to the fourth, but y to the 1/3 we can write as the cube root of y. And then z plus 1 to the 1/2 we can write as the square root of z plus 1. And there we go. That is our condensed expression of that log expression. Now let's try an expanding logarithms problem. So we're going to take a condensed logarithm and expand it. It's kind of like going backwards in the previous examples. So we're going to start off by noticing that there's a division of terms inside of the logarithm. So we can use the quotient rule. And we'll use the quotient rule to express it as the logarithm of the numerator, xy cubed, minus the log of the denominator, x plus 1. And now this is a product inside of the logarithm, so we can use the product rule to expand out that product. So we get log 7 of x plus log 7 of y cubed. And then we've still got our minus log 7 of x plus 1 at the end. And then lastly, this y cubed, we can use the power rule to expand that. We'll move the 3 out to the front of the logarithm. So we'll get log 7 of x plus 3 log 7 of y, and then minus log 7 of x plus 1. And then that's our final answer. That's the expanded form of this logarithm. For our final example, we'll do another expanding logarithms problem, and this one's going to be a bit trickier because we've got some roots inside. But the overall process is going to be the same. We see a quotient here, so we're going to use the quotient rule to expand this log into the log of the numerator, 8x squared, minus the log of the denominator, the cube root of yz squared. And now we'll go ahead and see that these are some products here. So we'll use the product rule. So here we've got log 2 of 8, and then plus log 2 of x squared, and then minus this log will become log 2 of the cube root of y plus log 2 times the cube root of z squared, because this cube root of yz squared is just cube root of y times cube root of z squared. Alright, so now let's go ahead and pretty this up a bit. We'll simplify. Log 2 of 8, well, 2 to the third is 8, so log 2 of 8 is just 3. And then we've got plus log 2 of x squared. Then we'll distribute the minus sign, minus log 2, and then we'll turn this exponent into a nice fraction. This is y to the 1/3, and then minus log 2 of z to the 2/3. Okay, so now it just remains to take these exponents and move them out in front of the logs. We can do that with the power rule. and applying the power rule here, we get 3 plus 2 log 2 of x, then minus a third log 2 of y, and lastly minus 2/3 log 2 of z. And that's our final answer. That's the expanded form of the initial logarithm. These techniques that we learned for expanding and condensing logarithms will come up again in future topics, such as solving logarithmic and exponential equations.